Good afternoon, everybody. Welcome to class today. First of all, I just want to say I hope you all had a nice little spring break last week. Hope you all got some rest. Especially, as we're moving into this final push here at the end of the semester. We only have roughly 4 weeks left here at the end of the semester, give or take a little bit. So, it's coming down to the wire, coming down to the nitty gritty, as it were. So I just want to remind you to, keep your head up, keep pushing. We're going to make it to that finish line here in a few weeks. Best thing we can do is finish strong. And this week we are talking about something brand new with programming and logic, as it is most weeks. And we're talking about working with files. And this is one place where we can kind of take our CLI, our command line interface, or console-based programs and really start to just send them to the absolute next level as we're talking about files. And the big thing about files being persistent storage. So what I'd like to do today for our live stream is to talk a little bit about why we use files, what the purpose of using files with our program is, and we'll do a demonstration utilizing some text files. And then next week for our live stream, we'll also look at comma-separated value files, or CSV files, in a little more depth so that you have an understanding of everything you would need to be able to do your module assignments. So today we are talking about files, and I think I would like to start our discussion of files with just at the beginning, just as simple as we can possibly get with our discussion of files, and then move on with it from there. So in terms of talking about files today, the first thing that I would like to talk about is, well, what is a file? What is a file? And you probably, have this understanding of how this works, right? What a file is, and maybe some idea as to why utilizing files in a program like ours would be pertinent, would be important. But a file is simply a named location on a disk to store related information, right? So we take some data, we encapsulate it into a format, and that is stored on non-volatile memory. Your hard disk, of a hard disk of some sort, whether it's, a standard hard drive, solid state drive, even something like, a flash drive or a memory card. Something where we have this sort of non-volatile memory where it's going to stay on there even after you stop the program, even after you reboot, whatever. You're going to have that data kept permanently in air quotes, because obviously, you could have some things that happen physically to these hard drives that are going to cause issues for you, but we'll say permanently as long as that drive maintains its function. So with that understanding of what a file is, we should have a better idea of why we would want to use a file. Because we want to think about this kind of in terms of every program that we've done up until this point. With every program that we've done up until this point, what we have is when we run the program, it's taking that program and it's storing all of the information and all of the data related to that program in volatile memory, in RAM. So whether we write it in REPL or whether we're writing it on our own machines, all of the data that's stored and anything that you enter into the program is put into RAM. And so when you stop the program or when you close the program, what happens is, well, everything in that volatile memory gets wiped. So any changes that you've made, any data that you've added via the command line, via the console, gets wiped away. And it's not there anymore. And, you can kind of think about it in terms of, the previous couple of modules that we were doing with lists and dictionaries. If we added an item to a list via the CLI, via the console, or we added something to a dictionary via the console, via one of our input methods, once we stopped that program, that data went away. And when we reran our program, we just had the base data that was hard-coded into the original program. And that's because that random access memory, that RAM, that is holding all of the data for our program while we're running it, that's volatile memory. So when we stop that, when our computers or the servers, in the case of REPL, when they don't need what's on that memory anymore, it releases it to make room for new stuff, to make room for other stuff. That's how volatile memory works. So that's kind of the idea behind files. We're making this shift from volatile memory to non-volatile memory so that we can store data that's entered in via the console. And so we can use these files for the future use of data. So the big key for the file in terms of what we're doing with it here is persistence. We want to be able to have our users enter in data and then go back and get that data again. We don't want it to be wiped away every single time in the way we've been dealing with our programs up until now. So when we're using a file in Python, when we want to read from or write to a file in Python, the first thing that we need to do is open it, right? So when it comes to using a file in Python, we can kind of think of it in the same way as like using a file or using a folder in real life, like a physical folder, right? Or like a letter that you get. If you want to read the letter, well, the first thing that you have to do is you have to open the envelope. And so that's kind of what we're doing here when we're starting to use a file in Python. The first thing that we want to do is we want to open the envelope. We want to open up that file so that Python knows how to read from it. And then when we're done with that file, we can close it back up. And that just kind of takes that data out of memory, out of that volatile memory. But the difference between file use in this sort of way versus regular data use in our regular programs is that it's written long-term to the disk before it's wiped out of that volatile memory. So we can kind of think about things in terms of the information cycle, right? Which is probably something that you've heard talked about before. This idea of the information cycle. When we're dealing with computers in general, we have an input. This input is put through some sort of process. And then the process is sent to the output. That's our basic data cycle or information cycle when it comes to how information's processed on a computer. So we have input, we have a process, and we have output. Now in the between times here, we have our volatile memory. So the input's placed into volatile memory so that while the process is working on it, it has this easy, quick, fast place to read the data from. It's then in volatile memory until it's pushed to an output, which is, in this case, our file. So this is our input, our output, our process, and in between times we have our volatile memory, our output here in our case being our non-volatile memory, our hard drive. And we can see that mimicked here in terms of the flow of execution for our Python file operations. We open the file, we take the input, we perform an operation on the file, we process the file, whether it's reading or writing or what have you, and then we close the file. So what I'd like to do is I'd like to go ahead and just kind of step us through these processes, step us through opening a file, step us through reading to or reading from or writing to a file, and then step us through closing the file. And that'll be what we do for today. So the first thing that we're going to want to do is we're going to want to open our file. And opening a file is relatively simple. But there are a few things that we need to remember as we open a file. So in Python has a built-in function called open that we can use to open a file, and this function returns a file object, which can also be called a handle. And then you can use that file object to read to or read from or modify the file. So in this case, we're just declaring it essentially the same way you would declare a variable. And you can see like the syntax here looks really similar to like our input function, the way we use our input function. We have a variable name. In this instance, we have a variable name f. And we've set it equal to open, and then our file name in parentheses and quotes. So we're opening that file. And in our first example here, that's if the file's in the current directory. However, if the file is in another directory, then we need to specify the full path to get to that directory. And when we open a file, we can open a file in read mode, we can open a file in write mode, or we can open a file in append mode. And the difference between write and append is going to be very important when we consider that later on in terms of how we modify our files. But let's start off just working with reading a file. So let's flip over to a REPL here. Let's see if I can find my REPL window inside of all the windows that I have opened up here. There we go. Let's flip over to the full screen view here. And so one of the interesting things is that we can work with files from right inside of REPL here. You'll notice that we have this files bar over here. And if yours is collapsed, you just click that document icon there to open up that drawer. And we can actually add more files to what we have here. So I can add a file, and I can just give it a name. I can call this like test.txt. So we'll start with the text file, and I can write information into this text file just like I would write anything else here. So let's put a line in here. Let's just put a little, we'll write, did it work? Question mark. That way we can kind of print out the results of what we get when we open this file in our console. All right, so let's start off. Let's switch back over to our Python window here. Notice that we have a main.py file and a test.txt file. So when I'm coding my Python, I want to be in my main.py file. And let's add my all my important stuff, right? So let's add my shebang. And I'm going to go ahead and add my main gate. So just like that. So now we have everything here in place. We can go ahead and write some code. So what I'd like to do is I'd like to just go ahead and create a function def read underscore file. And we will put a file name argument in here. So the first thing that we want to do is we want to open our file. So we can create a variable, f, we call it whatever we want. We can call it f, we can call it file, we can call it f name, we can call it whatever we want to call it. You know, it's just like a variable. We can call it whatever we want it to be. So we can say f equals open file name, because we're doing this with arguments, so we can make it more flexible. And so then, for the time being, let's try to print the results of f, just to see what it gives us. And so now behind our main gate, we can call our function read underscore file. And we can add our file name in quotes inside of the parentheses here. So that's test.txt. Now remember, if I head back over to my file here, I can see I have my text in here. So we can run this and see what it gives us. And this is what we end up with. io.textio wrapper name equals text, test.txt, mode equals R, encoding is UTF-8. So a little different than what you might expect or might have expected to see. But this is telling us that our open worked, right? We opened our file and our file is here. But remember, what this does is it creates an object for us. And so what this is giving us here is the information for our object. So we have to do some more manipulation in our code to be able to actually get the data out of this information. Or the information out of this data, I guess is probably the better way to put it. This information is processed data. So that's the way we open a file, though. We can tell, insofar as all that goes, that we were successful opening a file. And so from opening a file, we can also close a file. So when we're done with the operations to the file, we need to properly close the file, and closing the file will free up the resources that were tied with the file. And we do that using the Python close method. Now, we do have this one issue here when we're using the close method, where an exception is thrown before the file can close. So if there's some kind of problem, if there's some kind of exception thrown, if there's some kind of error message that you get before the file is properly closed, then this kind of throws a big wrench into the works, right? Like in our purposes with a REPL, not a huge issue, right? Because whenever you stop the REPL or whenever the REPL stops after the exception is thrown, it's going to release this data, this information anyway. But if we had a program on our local machine that we had written that throws an exception before it closes the file, then essentially what happens is it leaves the file open because it never got to the line of code that tells it to close it. And that'll continue using resources behind the scenes, which can ultimately be bad, if you keep using a computer's resources when you don't need to be. And so we can kind of fix this by implementing a try finally block. And so this is relatively simple. It works like a lot of the other stuff that we've examined in terms of our conditionals and loops and things. We kind of put it in a block. And really what this is a conditional. So essentially, what we're telling our computer in these sorts of instances is to try this. And if it's successful, you're good. And if it's not successful, make sure you close it. Or really, when you're done, make sure you close it. So this will kind of give it that opportunity to continue on working. And if it doesn't work, when you try it, it'll close it. So we can put a try block in here. And anything that we want under our try block is what we're going to do with our file open. And then we're going to add our finally block. And the finally block is what we're going to do after we're done with the file. So that's going to be our close. So we're going to put our name of our file object dot close. And so now we have this file closed. And we can put the parentheses out there. So now let's see what happens if we try to access this after it is closed. We'll add a print f again. So let's run this. Let's clear our console. And we see we still get it. But our file is closed at this point. We still get it. We can't work with it at this point, but we can still get the information behind our object. Because the object still exists. The resources from the file are just closed. So again, essentially what we're telling our interpreter with this program is we're going to try to do this. We're going to try to open our file. And then we're going to do whatever we want to do with our file. And then if that doesn't work, or if we're done with everything else, we're going to close it. And so that's our try block and our finally block. So just like that, we've opened and closed a file, and it's fairly simple. Right, and working with files in Python are it's a lot simpler than it might seem. So now what we would want to be able to do is we would want to be able to read from that file. We want to be able to get that data out of that file. So let's talk about how we'd read a file in Python. And so to read a file in Python, we must open the file in reading mode. Now, one of the things that we saw when we looked at our example is when we have our object here, we can see our object by default is in mode R. So if all we're wanting to do with our file is read from it, then we can go with what we have here with just our regular file open. But if we want to write to a file and then read from a file, we're going to want to do some different stuff. So, and there are various methods for us to be able to do this. And various different things here. A lot of this stuff is covered in your module material in terms of the way you can handle a file. But all I'd want us to do now is be able to get that data out of the file. So let's try something else. Let's try a for loop. Why not, right? So if we said maybe for item in F, we will print item. Let's see what this does for us. We got, did it work? Huh. Well, now we're getting somewhere, right? We're getting somewhere here. So let's add some more text to our text file, right? Let's add something like, it seems like it did. How about this? So we got 3 different lines of different text. Let's run this and see what we get. Did it work? It seems like it did. How about this? Now, one of the interesting things here is that we do have line breaks between all of these lines. And that's because that's in the file, right? Because when I get here to the end, I hit enter to go to a new line. So it's sort of reading every piece of data that's kind of in there, which is interesting. So that's one way that we could look at data and pull data out of a file. But there are some other ways. Because if I want that to be a little bit cleaner, I might want to use my read lines function. So let's add a read lines function in here and see how that changes my output. So let's add another little variable here, and let's call it lines, let's say. And we're going to call this f.read lines. So we're going to use a read lines function to look at all of the lines that are in my file. So remember that this is how it looks now with these extra spaces in between here. So let's see how this looks when we add our read lines function in here. And then change this from items in F to line in lines. And we'll print line. It's exactly the same. Right? It's just a little cleaner on the back end. But now let's look at this from a little different perspective. Like, what if I'm trying to be able to manipulate the data that's in this every single time. Like if I want to be able to load my data up from my file and then use my file to kind of pull data in so that we can manipulate it and do some things that we've done in the past with like dictionaries and lists and things like that. So let's say I want to take these lines and turn them into a list. So let's see what we end up with if we just print lines. And let's comment out this for loop here. Let's see what we end up with if we do this. Did it work? And see, there's that new line escape character. Did it work? It seems like it did. How about this? So that shows you that those new line escape characters are in there, right? And that's why we have that extra line in between our other lines. And what does this look like to you all? How does this look? Right? We did this a couple of weeks ago, close to a month ago now. This is a list. So we can take that read lines, and that's a list, and we can treat it just like we would any other list. So what if we wanted to make this a little bit cleaner? What if we wanted to do some different stuff with it? Well, this is where things get interesting, right? So let's create ourselves another list and do some sanitization here. So maybe I want to take and I want to create, we'll call it san underscore file equals empty list. And maybe let's go through this lines. For line in lines, maybe we can check those last two characters. So let's see here. What would be the easiest way for us to do this? Maybe we could if it's greater than the last, if the index location is greater than the last item, or maybe we can let's see how that would work. Let's say print line dot index. Is that right? Is that what I want? No. So for line in lines, we can print line, and we get that. Let's go ahead and get rid of print lines here. Let's see here. I probably want to I'd rather maybe it's lines.index line. Yeah, there we go. That's what I want. Lines.index line. And that gives me 0, 1, 2. So I can add if lines.index line is less than len lines minus 1. So in this instance here, what is len lines? Well, we have 3 lines in our file here. They're 0, 1, and 2, so it's 3. With the way this works, as we add lines to our file, right, we are hitting the enter key in between lines, so the last line doesn't have the escape new line character on it. So as long as it's less than whatever items in the last index location, we should be able to strip the final 2 characters off of that item using string manipulation to be able to get rid of that new line character while we're working on it. So maybe, and we'll append it to our SAN file. So that would be SAN underscore file dot append line and let's see here, what would be the best way to do this? Len line minus 2. Is that gonna work? I had a different demo plan for today, and I'm kind of taking this off the reservation just a little bit, so then we can print SAN file here to sanitize, to see if this did what we wanted it to do. Let's test it out. Did it work? It seems like it did. We're missing the last one because we need an else condition here. So we're going to add an else. SAN. We're going to add an else for SAN file.append line. So we don't do the string manipulation on it. So now if we run this, those are all sanitized lines. So I can go back in here. I can add some more lines. It took my punctuation out because that needs to be -1. There we go. That's what we want. So now we can add some more lines here. Now we've sanitized the lines and we can work with them like we would. Pretty interesting, right? Sanitized the lines, got those new line characters off the end of them that we were putting in there by doing this because we're hitting enter between lines. And that gives us a nice sanitized list that we could just work with like a list in our program, which is pretty good. And so, you know, we call this read file. This could also be load file, right? Like SAN file could be at the global level, right? So I could pick SAN file and put it here and have that equal to an empty array. Call on my global keyword for SAN file. And now I can use that san file list of sanitized lines from my test file in any part of the program, which is pretty nice. So by doing this, what we're able to do is, one, we're reading from our file, and we can read from our file quite easily, as we've seen, by just, writing a loop and having it traverse our file. We could also do our read lines function, as we've done here. Now, as we've seen here, if we want to kind of break it down and work with everything on different lines, we can bring it back in and we can sanitize it like this and put it in some kind of temporary storage to where we can write it like that. So that kind of gives us half of our equation. So what I'd like to do is I'd like to kind of look at the other half of the equation, which is writing the file, or writing to the file. And remember, this is a 2-week module, so we will do more next week, right? But I'm able to read from the file this way, and I can write to the file if I do it in another way. So that's reading from the file. Now let's talk about writing to our files. And so in order to write into a file in Python, we need to either open it in W mode, A mode, or exclusive creation, which is X mode. When we open something in X mode, that's essentially we're creating a new file there. And when we do our big example at the start of next week's stream, we'll do something with X mode to where we create a new file and then write into it. So what I'd like to do today is I'd like to just use W mode. And next week we'll look at append mode a little bit more and exclusive creation mode a little bit more. But one of the things with W mode is that we need to be careful with W mode, because it'll overwrite all of the data that's already in our file. So if we have data that's important in our file, and then we write, we have our file in W mode, and then what we want to do is add something to it, but instead what we end up doing is we erase what we have there and just put something new in there. Right, like we can see that if we do an example of that, and we'll do that in just a moment. But when we're writing a string, that's a sequence of bytes, and that's done using the write method. So you've seen the read method. So now what we got to do is the write method. So it's fairly simple. So let's head back over to our sample file here. And so what I'd like to show you first is why not this, or why we wouldn't open a file in write mode. So I'm going to create a new function. I'm going to call it def. Let me switch back over here, full screen. Def write file. And we'll add the file name in here as an argument again. Just like that. Now, eventually we are going to use this global list again, because that's kind of the trick to getting around the problem that's created by using W mode. But what I'm going to do here is I'm going to open my file in write mode. So that's going to be open file name. So we'll say F equals open file name W in quotes. That opens it up in write mode. And so we can see the difference here. If we have something, opened in write mode, we can print F here the same way we printed F before and run our write file function here and see that our mode is W here now. Remember, it's read by default like this. Now it's W in our write file function. And so if I had my file.write, hit the wrong button here. What I might want to do here is I might want to write lines. So if I had this, and before we do this, I'm going to take and let's already did it to us, right? Because we opened that file in write mode and we didn't write anything to it. So now it's erased all of our text from it that we had in there before. Which that's a big oopsie doopsie. Let's see, can I Control Z this? I'm not sure if I can. I cannot. So we'll just add some dummy lines here. Line 1, line 2, line 3, line 4. And now you can kind of see, we can write lines. But when we write the lines, we can say something like, what is it? Something like f.write new line. When we're in W mode, that's going to override everything. So if I run this now, nothing on the output because I didn't tell it to put anything on the output. But if we look at our test.txt file, it just says new line now because it overrode everything. So let's bring back that line 1, line 2, line 3, line 4. And now let's write these lines in a bit of a different way, because when we load our file up, we can load it with our read file. So let's read file and add our file name, which is test.txt. And we can also write to our file using test.txt. But in our write file here, let's pull in that global san list or san file. So now we have all the sanitized things that we got in here. So maybe we want to get something new here. We could add that as an input with a while loop. So maybe while true x equals input enter list item to add, or we'll say f to finish. If x equals f, we will break. Else, we will san file dot append x. Then we can open our file, and we should actually have this in a try finally block, right? So we'll say try to open our file at that point. We'll get rid of that. Write a for loop that'll loop through our list. So for I in san file f dot write I, and we can concatenate that with a new line character if we want to, or we really, I don't think we have to. That would kind of break this last. That'd kind of break what we did here, because then we could just do everything with that instead, though, so it's fine. And then we can finally, and actually that should be over 1. Got to make sure we keep our tabs in order. Finally, f dot close. So now we're reading from our file, and when we read from our file, we're going to load it into our SAN file. So that's going to load SAN1, that's going to load everything into our SAN file. Then we're going to have the opportunity to write stuff to our SAN file. And then we're going to write the contents of our SAN file to our file. So we can run this now. We get that printed there because we have that print line here, right? So we can add line 5, line 6, line 7, F to finish. Now I can check my file over here. I have line 1, line 2, line 3, line 4, line 5, line 6, line 7. Right? And I can either backspace that there, or I can change my code here and just get rid of this part and this here. So that might be what I want to do instead. So that when it sanitizes everything, it's going to remove those new line characters off of everything. And so now when we run this again, we can see it sanitized our list. We can add line 8, line 9, whatever we want. And we can see it in our persistent storage here. And one of the great parts about this is if I take and refresh this, that file, that txt file that we've created there, that doesn't go away. So if I want to come back here and do this, work with this again, it's all right. That data is still going to be there. See, I just refreshed. It still has all that data. I could run it here. It's going to still have all that data. Persistence is key for what we want here. So again, this is, we kind of did a little introduction this week. We're going to do some more stuff next week. It is a 2-week module. So as you're, if you want to start working early and then send your questions in, we can cover some more questions on our live stream for next week. But for this week, this is where I want to stop because we're hitting the 1 hour mark. So if you have any questions, please let me know. I can either answer them for you personally, or I can answer them in a bigger, a bigger picture sort of situation. However you want to do it. But that's all that I have for you for this week. I'm gonna, hang out and chat for just a minute, just in case anybody watching live has any questions. But that's all that I have for you for this week. Thank you for watching, and we'll see you next time.